Okay, so here are our objectives for today's lesson. By the end of this video, we should be looking or able to understand how nuclear fusion can be used to generate electricity and what happens when atoms undergoes fusion. Okay, so what is nuclear fusion? Now on the screen here we can see that we've got one proton here and we've got another nuclei here that's got one proton and one neutron. Now this nuclei here that contains just the one proton is a hydrogen nuclei. Now over here where we have the one proton and one neutron, it's an isotope of hydrogen. Same proton number or atomic number, but here we've got a slightly different mass. Now this one is known as deuterium. Now any of you that understand French will know that deux means two, and here we've got an atomic mass or a nuclear mass of 2. So what happens during nuclear fusion? Now during nuclear fusion what happens is that the two nuclei overcome their electrostatic forces and they combine. So now the hydrogen and the deuterium have disappeared. Now what we have is a nuclei of helium. Now you'll notice here that we've got the two protons that allow it to be helium, but we've only got one neutron, which means this is an isotope of helium. Now here is the nuclear equation for this reaction. So here we've got the atomic number of 1 for both the hydrogen and the deuterium, and here we've got the masses of the hydrogen and the deuterium. Now you'll see that as they combine you get the two protons here and you get the total mass. So how do we get the energy for this? Now the energy comes from, during the fusion process we get the energy, or a small amount of mass is lost, and that is given out in the form of energy according to Einstein's equation of E equals mc squared. So the mass that's lost is times by the speed of light squared gives you that energy. Now what we've just seen in the previous section was how we actually get nuclear fusion. Now one of the big problems is that the amount of energy required to overcome the electrostatic forces. Now as you get two positive charges coming towards each other, say if we have another look, so as the proton comes towards it, it's likely to be repelled by the other proton. Now this means that it's very difficult for this to fuse together. Now what needs to happen is we need to be able to overcome that energy. Now it requires a hell of a lot of energy to be able to do this, and the only place that it occurs naturally is in stars. Now stars are fueled by hydrogen, and it's those isotopes, hydrogen and deuterium, that allow the stars to actually fuse to make the helium. Now some of them can actually go on to do even more fusion, where we can get bigger and bigger elements all the way up to iron. But our star, it is mainly hydrogen and helium. Now obviously for a star to do this we need to have the right conditions, and these conditions are the high temperatures and the high pressures. So you need high temperature, high pressure in order for nuclear fusion to actually happen. At the moment nuclear fission is the only way of generating nuclear energy. Nuclear fusion is something that we could consider for the future. The only problem is that, like we've just seen, it's only stars that have the naturally high temperatures and pressures to actually do this. And it's actually going to take about 14 million degrees to actually get the temperatures high enough, which is realistically it's not going to be possible on Earth. Now, once you get the reaction going, so once we get this actually happening, the energy that's released from the E equals mc squared, the energy that's released is enough to provide that 14 million degrees. So once we can get it going, it is sustainable. But it's getting it going that's the problem.